simple harmonic motion where it's given that a body, a particle performing SHM, okay, has velocities whose velocity is given to you. Okay, yeah. So the particle is performing SHM, simple harmonic motion. That particle is in simple harmonic motion. Okay, and the body is has velocities of 3 centimeter per second and 4 centimeter per second respectively, the velocities. Okay, so for that particle, okay, the velocities given are 3 centimeter per second and 4 centimeter per second. These are the two velocities as given to you for that particle respectively when the displacements are 4 cm and 3 cm. So the displacement are 4 cm and 3 cm. Okay, so the corresponding displacements are, when the 3 centimeter per second is the velocity, then the displacement as given into the question is 4 cm, and for 4 cm per second of velocity the displacement is 3 cm. We need to find the amplitude, its time period and maximum velocity. Time period and V max, that is max velocity of that particle. Okay, that we need to calculate. This is the data given to you. Now you know that the velocity v of the particle performing SHM when its displacement x is given by this formula, v equal to omega root over of a square minus x square, right? Where a is the amplitude, x is the displacement, omega is the angular velocity, and v is the velocity, right? Now we have been given that v as 3 centimeter per second for displacement of 4. So just put up the value over here. So here we can write it as, when you just do a square on both the sides, it will be written as v square equal to omega square into a square minus x square. This root will be eliminated, right? Now when the velocity is 3 centimeter per second, just put up the value. It will be 3a square and omega square will be as it is, omega square, then a square is the amplitude which is not known to us, minus x square. So this will be 4 centimeter. At 4 centimeter of displacement, velocity was 3 centimeter per second. So put the value of x as 4. So this will be 4 square which is equal to 16, right? So this is one of the equation which we have derived, right? For the second parameter which is given into the question, that 4 centimeter per second is the velocity. So putting the values again into this formula, okay, into this formula, one value is this one, another one will be like this, 3 square. In place of 3 square, the velocity is 4 centimeter per second, so it will be 4 square equal to omega square a square minus x square. So 4 centimeters per second is the velocity at 3 centimeter of displacement. So this will be 3 square which is equal to 9. So this is your equation number 2. Now do one thing, divide equation number 1 by equation number 2. Okay, divide equation 1 by equation 2. When you divide it, what you will get, 3 square by 4 square, that means 9 by 16 is equal to omega square a square minus 16 divided by this denominator omega square a square minus 9. So here you can see omega square and omega square will be cancelled out, right? And we have a equation into the form of a square. So from here the a will be calculated. Okay, that is the first part. That means our amplitude will be calculated. So just solve this simple equation. Equation in one variable. 9 times a square minus 9. That means 9 times a square minus 81, cross multiply it, is equal to 16 times a square minus 16 into 16. So what is the value of 16 into 16? Just calculate it over here. 96 is 256, right? So just write the value of 256 over here. Now 16a square minus 9a square will give you 7a square. Okay, and when 256 will come into the LHS, it will be coming as 6 minus 1 is 5, and then 15 minus 8 is 7. So 175 equal to 7a square. So this will give you the value of amplitude, which is equal to 175 by 7 root over. Okay, so just from 7 it will be cut. 7 2 times 14, 35, 75. So a square, the value of a square is 25. So the value of a is root over of 25. So the amplitude is coming to you, that is 5. So first part of this question is solved. Okay, that means the amplitude is 5. This is your answer. That is the maximum displacement is your amplitude. So amplitude is calculated to you. Now the second part is the time period, which is not known to us. Now let us solve the second part of the equation of this numerical. Okay, now since we have already divided and calculated divided equation 1 by 2 to find out the value of amplitude, we have calculated 5 centimeter. Okay, the unit will be centimeter. Now just substitute this value into the above equation. Let's say this one. Okay, equation number 1. Okay, so when you substitute the value in equation number 1 in equation 1, then we will having the this one with us from equation 1. That means 9 is equal to omega square into a square minus 16. So put up the value of a square as 5 square. That means 25. 25 minus 16, right? We have just put up this value of a into equation number 1. That's it. So this will give you the value of omega square. In this way, we will be calculating the value of omega, which will give you, and omega equal to 2 pi by t. This will give you the time period. Now 9, just solve it. 25 minus 16 is 9. 9 by 9 is 1. So the value of omega square is 1, which will give you the value of omega as 1. Okay, 1 radian, right? But omega equal to 2 pi by t. Omega equal to 2 pi by t. So we can write omega equal to 2 pi by t. Therefore, the time period is calculated as 2 pi divided by omega, which is equal to 2 pi divided by omega value 1, right? Divided by 1. So this will be equal to 2 pi seconds. So 2 pi by 1 is equal to 2 pi. So 2 pi seconds is your time period. Okay, 2 pi seconds is your time period. So in this way 2 pi seconds is the time period which we have calculated, right? Now the third part of this question is that what is the Vmax? Velocity will be maximum when the displacement is 0 over here, right? So Vmax can be calculated as for the third part, Vmax is calculated as at x equal to 0. So when x will be equal to 0, right? When x will be equal to 0, then b square equal to omega square a square, or b equal to omega a, right? So this will give you omega times a, right? This is the maximum velocity, and omega is 1, which we have calculated. You can see over here omega is 1 and a is amplitude is 5, right? So the Vmax value is calculated as 5 centimeter per second. This is your answer, right? So the third part of the question numerical is also solved, that is Vmax is 5 centimeter per second, right? So in this way we have solved this question. Okay, so students, it was a very easy question and from simple harmonic motion where a particle was performing SHM, and these are the two velocities on the with these displacements on these displacements. Okay, we need to calculate the amplitude, time period and Vmax, which we have calculated by using the formula V equal to omega a square minus x square. Just when you square both the LHS and RHS, you get V square equal to omega a square minus x square. Now V will be, just put up the value of 3 centimeter per second at displacement of 4. So in place of V it will be 3, right? And in place of x it will be 4, right? So just put up the value, then this equation number 1 will be derived, and putting the second set of values you get the equation number 2, and dividing equation 1 by equation 2 you will get the value of, and solving, this will be equation in one variable of a. Okay, then you get the value of a as 5 centimeter. This is your amplitude, so which is written over here. The first part is solved, and the second part is the time period. Time period is given as, just put up the value of this a into the above equation number 1. You get 9 equal to omega square 25 minus 16, which will give you the value of omega as 1, and omega equal to 2 pi by t, so which will give you the value of time period as 2 pi by 1 seconds, that is 2 pi seconds. Now Vmax equal to omega a. How? Because just you can see V will be maximum when the displacement will be 0. When x will be 0, this V square equal to omega square a square, right? So that's why Vmax is written over here as omega times a, right? Which is equal to, and omega, the value of omega is known to you, that is 1, which we have already calculated over here, you can see. So put the value of 1 into a, and a is calculated as 5. 1 into 5, that is 5 centimeter per second. So in this way the third part of this question is solved, this one, 5 centimeter per second. Thank you so much for watching, students. Keep on learning. Happy learning. Bye bye.